Good afternoon, everyone. We'll start this session in 2-3 minutes. Thanks. So, good afternoon, ladies and gentlemen, and welcome to this webinar where we'll be speaking about an introduction to the energy storage technologies. This webinar is sponsored by Jinko Solar, which is a leading global energy company that is specialized in solar PV, energy storage, among other applications. If you are not able to join us via this Zoom broadcast, you are welcome to join us through the newly created Jinko Solar Facebook page for Sub-Saharan Africa, where this session will be broadcasted, and you will find as well this link to this page on the chat section in this session. For you who cannot join today and for your friends and colleagues, please tell them that they can watch this recorded session afterwards on the YouTube channel of Solar Arabic, where you will find this information, and we'll be sending you over the link and the presentation materials just after the presentation. Before we start with a couple of admin topics, I'd like to ask you please to write to me in the chat box if you can hear me well. Please just write me if you can hear me well in the chat to make sure that everything is fine and we can continue the session. All good, very good. Okay, perfect. I see the response is coming. Thanks a lot for your feedback. The other thing that I want to say, please don't wait till the end of the session to ask your questions. You'll help us a lot if you ask the question as soon as you have it in your mind, and please don't write it in the chat section so it doesn't get lost among other chats, but there's a dedicated session which is the Q&A section. Just click on Q&A, add your question, and this way you guarantee that your question will be answered during this session today. So Before we start, I'll introduce myself. My name is Munif Barakat, and I am an engineer from the Solar Arabic platform, which is the biggest renewable energy platform in the Middle East and African region. Today, I'm joining you from Berlin, Germany, and not joining just the webinar, but joining you for the good weather as well. Like in Africa, we have today 34 degrees, so I can't wait to get outside to sit under the sun to charge up with some vitamin D. But before that, we will be speaking today with you how to charge up our batteries, especially from the sun. And for that, I am very pleased to have today Mr. Titus Koish, who is a technical services manager at Jinko Solar Sub-Saharan Africa team. And he's joining me today with very good experience in electrical engineering and demonstrated history of working in the renewable energy sector, manufacturing, and the power sector. And Mr. Titus will be introducing the BESS technology today, which is the battery energy storage solutions. We'll be talking about the applications of this technology in the C&I sector, residential sector, and the utility sector. And then we will talk about the different battery technologies that are used to form these BESS solutions. And then you will hear a new terminology today, if you didn't hear about it from the Jinko Solar team before, which is the JESS. And that will be a question for Titus later on to tell us what does it stand for and what is the offering of Jinko Solar in the world of renewable energy storage solutions. Now, before we get into the session and before I hand over to Titus, I would like to know a little bit about you, please, for those who joined us through this following poll. I'll ask the first question. And if you can tell us, please, from what region are you? Because this webinar today is focused on Africa. We expect that most of the attendees are from Africa. For those who are watching on social media, just please write in the comment section below the live stream video from what country are you joining us, so we also know where you join us and where there is a big interest for solar. And from the results so far, I see that the biggest interest is in Eastern Africa. 30% of the people today with us are from Eastern Africa. We have from Southern Africa, 20%, then West Africa, Central, from North Africa, and for some people from the Middle East as well and from other places. Thank you all for joining us today. We're very happy to have all of the African content represented today among you, our attendees. That's a very big pleasure, and that's the purpose of this educational series of webinars that we are doing with Jinko Solar. Next question would be asked, we would like to know from what industry are you? Are you working for a developer or an EPC or a solar installer in your country, or do you work in a battery specialized company? Please let us know. We'll be happy to know your background. This will help Titus and myself to customize a little bit the session as we go to fit your interest. And I see that the biggest portion, 25%, is from solar installers. There is around 20% from EPC, 20% from academia. There are some developers, OEMs, and battery companies as well. So I think that covers the whole spectrum of interest, potentially interested parties in this session. And we're happy to have you all on board to share this first webinar in this educational series that we started with Jinko Solar Sub-Saharan Africa team. So please, I would like to then ask you, please, Titus, to share your screen with us, the presentation, and then I can hand over the presentation to you, please. Yeah, your presentation is in full screen.
It's okay. Hello, Monif.
Hi, Titus.
Okay. Hello, everyone, and thank you so much, Monif, for the kind introduction. And as I said, you're in Germany. Yeah, I'm actually based from the East Africa, and I'm very happy that a larger percentage of the attendees are actually from East Africa and also the African region in large. So our target for this training was ideally for the East African region, not for the East African, but for the Sub-Saharan Africa region. And yeah, but we also appreciate to have attendees from other regions as well, like Europe and also Middle East, that we've had some very good partners Yes, for Jinko Solar, we have different regions. We have the Sub-Saharan Africa region, also the Middle East region, the MENA region, and also Asia, and also other countries, other continents as well. So I think, Monif, I don't have to introduce myself. I think you've said it so well, and I appreciate about that. So I will briefly, just introduce the topic and what you're going to discuss about today in terms of our agenda, and also give brief information about the company as well, for the sake of everyone else who might not be knowing more about Jinko Solar. So, so this is going to be a brief content of what you're going to discuss today. That is briefly about Jinko Solar. It should take just a few minutes. Then also some key storage solutions or other technologies in the African regions, which is also applicable in other regions as well. And also we'll talk emphasize more on electrochemical battery storage, which is quite dominant in the Sub-Saharan Africa regions. Then I will also, I think Monif mentioned about JESS. JESS is more of Jinko energy storage solutions. So these are some storage solutions that we launched. I will show you about that as well. I'll tell you some brief info, but not talk so much about that, because we can also share the information that is after the webinar and to everyone else. And we always try to make this information available at any given time. So Jinko Solar, I know most of you might be knowing about Jinko Solar. It's when you talk about solar PV modules, of course, what comes into your mind is Jinko Solar. So Jinko Solar is a module manufacturer, is a PV module manufacturer. So we were established in the year 2006, doing production of solar PV modules way fast, and also cells. And we managed to top in terms of module shipments from the year 2016 to 2019. And currently, close to 70 gigawatts of PV modules, of Jinko Solar modules, have been installed. And that translates to close to 12.6%. That is the current market share. So this tells you that for every 10 modules, at least one would be from Jinko Solar. So we've advanced, because being an industry leader in terms of technology, we've done so much of developments from the module side, also from the energy storage side, that we're going to talk about today. And recently, this last one is that we managed to break the cell efficiency record. We're now at 25.25%. So this is the highest cell efficiency for our N-type cells. So, and yeah, as I said, as a manufacturer, our core business is solar PV modules. We are manufacturers. We are the manufacturers. We do the manufacturing from the wafers to the cells, all the way to the PV modules. And currently, we have a total capacity of close to 30 gigawatts of global capacity. And yeah, we categorize our PV modules into two different series, that is the Tiger series and the Tiger Pro series. So I want to talk so much about this today, but you can always find all this information from our websites. And also, if you need any specific requirement, we can always send it to you. And just briefly is that the modules that we do sell in the market is only high efficiency monocrystalline modules. High efficiency in the sense that the efficiency is more than 20% and up to more than 21%. Yeah, and we have different cell sizes from 163 and 182 millimeters, and also 166 millimeters. We've also done categories of different applications, from the smaller modules, that is in the order of 100 watt peak to 550 watt peak. So, and also the other thing is also our solutions that we also do offer is that we also an energy storage supplier, because we are more of an integrator. So we are working with top OEMs to integrate energy storage solutions. And the energy storage solutions that we provide, and we're also going to give you some bit of background today, is of course for different applications. That is from residential applications to C&I applications and utility scale. So we do these categories to have different types of solutions. Like now, to just give you some brief highlight, is for the residential solutions is between 1 kilowatt hour to 50 kilowatt hour. Then for the C&I, from 50 kilowatt hour to 1 megawatt hour, or closer to that. And for the utility scale, that is more than 1 megawatt hour. So I will, before the end of the presentation, I will briefly share you some of the solutions that we do offer. Now, without further ado, I want to introduce the topic that is on energy storage technologies in Africa, with more focus in Sub-Saharan Africa. So before we discuss on the technologies, I would like to give some brief highlight on the energy storage, or rather some brief introduction on energy storage. So the principle of energy storage is, from its name, the energy storage is more of, as I would twist it this way, that we are storing energy. So I would define is it's more of the process of capillary energy that is produced and storing for a later use. For the case, why is it very relevant? Why is energy storage very relevant? Because if you take a case like the most energy sources available in most of the energy sources available globally, or even in Africa, you find that most of these energy sources are mostly from renewable energy, and renewable energy is more of variable, and ideally this needs to store this energy so that we can be able to justify and also meet the load demands, because the load demands are also variable as well. So in order to meet the load demands, we need this ideally needs to store energy. And so just to give a brief summary about energy storage, I would summarize into 3 main points. That I would say that energy storage is a tool to perform 3 main functions. One of the key functions, as I said, is that most of the sources of energy, whether renewable or not renewable, that you find them that they're of course, they're not they're variable in terms of the energy source, and this need to store. So it acts as an intermediary between the variable energy sources, that is, or rather the source of energy, and also the variable loads. And the other thing is, the other function, or rather with the energy storage as a tool, is to, of course, maintain also reliability of power and power quality. So when it comes to reliability, of course, you think about issues like very poor grids, like in most of the countries in Africa, where we find very long hours of outages, and we need to store energy, of course, to cater for all those hours of outages. We've seen in some countries, or rather in some regions, that power outage can even reach to more than 24 hours. So ideally, you need power for those periods of power of outages. So ideally, it's to be able to have some reliability of power as well. And on the utility side as well, of course, energy storage also plays a very important role in terms of improving our transmission systems and also distribution systems. We are going to look into different applications. I will notice in different aspects that it will really be of essence. So for the application scenarios, currently globally, I found this report from IRENA published in 2017 detailing different application scenarios for energy storage. And ideally is that we can classify this into the different, that is from the utility side. Like from the utility side, we can also look into application scenarios of energy storage in the C&I segment, and also for the residential segment. And also there's something also worth noting is also in the transport sector, because in the past few years, we've seen rapid developments in the transport sector in terms of having EVs, or rather electric vehicles. So with the electric vehicles, we find that energy storage will be of essence. And for the customer energy management systems or services, that is, or I would say CEMS, and of course this details now when it comes to mostly the C&I segment. As I said, one thing to ensure is that we need reliable power and also good power quality, and also when it comes to of course increasing PV generation, because if you're having a renewable energy source, let's say from solar PV, and you need to increase the renewable energy fraction, then that means energy storage will play a very important role in that. And for the transmission as well, that also the utility, that is in terms of transmission infrastructure and also the distribution infrastructure, you can see also that it also plays a very important factor. And there's also something I think we're discussing with Monif, I think yesterday or today, about some also ancillary services, like in some of the developed countries, like for example, black sat, it can also act at that, because it's always known that renewable energy sources cannot really support black sat, but with battery storage, that means that we can easily achieve that. Also, other ancillary services like frequency regulation, voltage support, etc. So for energy storage, is that why is it that this huge demand for energy storage in the African market for the last few years? Is that one, of course, it's satisfaction. We can look into the satisfaction levels in terms of the grid, the stability of the grid, and other the power quality and also reliability. So we find that most of the African countries, we do have some very poor grids and long hours of without power outage. Without power. So that means ideally we need to enhance that. And also for this segment, the tariffs also do vary sometimes, in that the tariffs at peak periods and also off-peak periods do differ. So most of the clients in the same segment would prefer to buy low, that is to buy power at off-peak periods, which is sometimes very cheap. Then that is stored in batteries, and of course, or batteries or any other energy storage technologies. Then of course that is used at high demand periods, like the peak periods. So in that is going to generally lower the cost of production, because we are lowering the cost of the loss of power. And again, the other key driver is also that most of the customers, or rather most of consumers would ideally prefer to go completely off grid, either because of the reliability of the power, or because also because of the reliability of power, or also because of the cost as well. So that is also one thing that is really been a very good market driver for energy storage. So so for energy storage is that there are different types of energy storage solutions available in the market. That is globally, and also in the Sub-Saharan Africa region. So I've just given some brief classification into 5 categories. That is from mechanical and thermal. It's mostly used in the utility segment. Mostly used in the utility segment. For the mechanical, of course we do have pumped hydro and also compressed energy storage and also flywheels. So you might not really find this in most parts of the Sub-Saharan Africa, unless for developed countries in Sub-Saharan Africa, like for the case of South Africa, and also for thermal. And yeah, the other 3 is this quite some interesting development in the other regions, like now looking into the electrical energy storage. So this, when talking about the electrical energy storage, is we're really talking about supercapacitors and also superconducting magnetic energy storage devices. So it's also getting traction in some of the markets, and that is now for small installations and also getting to utility scale. Of course, it still has, for electrical energy storage, it still have the disadvantage of a very high cost compared to other energy storage technologies. But we're hoping that maybe in the next few years, the cost will be optimized and it's going to be quite competitive. Then also hydrogen, or other chemical energy storage, is ideally more of a way of storing energy that is through hydrogen. That is, it's more of the process of creating hydrogen, that is from electrolysis process, that is using power, let's say from renewable energy source, that is to generate hydrogen. Then the hydrogen can either be used in either directly to combustion fuels, or also can be used as fuel cells as well. So it's also getting some very good traction in the market. The only problem is also on of course the cost, that it needs to be a little bit optimized. Then also now for the last type, that is electrochemical energy storage technology. It's something that is been in existence in the market for the last time, and it's also the technologies are quite mature. And yeah, it's predominant in most of the regions in Sub-Saharan Africa, that is spanning from all the way from lead acid, also the advanced lead acid, or rather lead carbon. We also have lithium ion, sodium sulfur, and other technology as well. There is also flow batteries, that is with vanadium and zinc bromine, which usually gain some bit of developments in the, like for the case of Southern Africa, although there's still some bit of concerns with regards to the availability of vanadium and also the bromine aspect that is dangerous to the environment. But generally looking into the overall market share, is that electrochemical energy storage technologies is actually predominant in the Sub-Saharan Africa region. So yeah, so now is that US this year, that is a US Trade Development Agency, actually conducted a very good report to see on the developments, relevance of different technologies, relevant for different energy storage technologies in the Sub-Saharan Africa market, with main focus in Southern Africa. And if you look clearly into this chart, you will notice that it's actually depicts on what's happening in the market. Like now is that you'll find that most of the technologies that are actually present in the market currently are more of electrochemical, like mentioned in my previous slide. You can see all these technologies except the small compressed air energy storage technologies and also flywheel. You find all these actually electrochemical energy storage technologies. And we can see the relevance, like for the case of sodium sulfur, it's been quite, it's been there in the market for the last few years. And the relevance is that it's actually predict that it's not going to last for more than last year. There are still some few projects, of course. It has its own share of challenges that we're going to look into the next slides. So, but for lead acid is one of course, it's still previously had some very huge market share in the Sub-Saharan Africa region, and the main reason is the cost. And it has its own limit of challenges, but it's still in existence. And also, we've seen developments of lead acid in that they've added in carbon. So currently we have the advanced lead acid, or rather we can say lead carbon energy storage. So with the advancement to lead carbon, so that's why we still have it in the market. We still have it in the market, because with lead carbon, that means it has more, of course, a number of cycles compared to the previous lead acid. So it will still have some presence in the market, but in the next 2 or 3 years, it will start fading away from the market. And by 2025, it's projected that is not going to be in existence in the Sub-Saharan Africa market. The other thing is for lithium ion, you can see it's, of course, it's been gaining traction the last few years, and it's a project that is going to be in existence in the market until more than 2030, and unless there will be other alternatives. And the main reason for, of course, for the increase in the uptake of lithium ion is because of the optimization in the terms of the technology and also the manufacturing. So we've had that the cost of lithium ion greatly reduced for the last few years. Like comparing the last 5 years, the cost has actually reduced by more than 30%. So that is actually something that is quite encouraging. So the other technologies as well, like now the flow batteries, like vanadium flow and also zinc bromine, is not been in existence so much, but it's also gaining traction, of course, with the developments. And of course, they have their own disadvantages. Like I said, for vanadium, that is the cost. For bromine also, it has some, bromine will have, or is projected to have some effects on the environment, that is hazardous. So that is actually the main problem with that. So this is just to give you an highlight on how the industry is at the moment in terms of energy storage technologies, and also in the next few years. So I've given you an overview, just a general overview in terms of the technology relevance in the market. And of course, to understand the reasons why we have these technologies being relevant in the market and why they are fading. Some are fading away from the market and some are coming in, and because of different factors that we are going to look into. One is, of course, the technology maturity. We're also going to look at the risks and advantages, disadvantages, and also different applications as well. Like for lead acid batteries, as I said, it's quite mature technology, but it has its own limitations, like the number of cycles and also the depth of discharge, and also the generally the lifetime of the battery. It actually projected not to last for more than 5 years. So that means that other technologies are coming up, like for lithium-ion supercapacitors, and also triple batteries with quite some very good lifetime. So there's some of brief comparison of the different technologies. As I said, from lead acid, of course, with the development of lead carbon, or rather the advanced lead acid, you can see this slightly improvement in the number of cycle life, and but the DOD is also still limited compared to other technologies like lithium-ion as well. Of course, even with lithium-ion, it still has its own disadvantages as well, and advantages as well. Like of course, in terms of operating environment, the operating environment needs to really be controlled and to be able to have optimal operations. And also, if you look into the number of cycles compared to other storage technologies like the spark capacitors and also other thermal or other mechanical storage solutions, is that it has quite some short life cycle compared to those technologies. But the main advantage for the lithium-ion is that it has different cell chemistries for different applications, and also there's also constant improvements as well. So this is just some brief comparison. I know you will have the presentation thereafter, then you can deeply look into the different advantages, also the disadvantages, and also we have the applications, different applications, including auxiliary support, grid infrastructure support, and also customer energy management services as well. So again, this is still part of course, the technology relevance in terms of the life cycle, the number of years that the batteries can last, like for lead acid from 3 to 5. For advanced lead acid, you can see the development up 5 to 10. And also nickel canadium and lithium-ion as well. You can see lithium-ion has some quite competitive, that is 10 to 20. You can see also this for supercapacitor more than 20. But I said the disadvantage is, of course, the cost. You can also look at different depths of discharges, that is from 50%, 80%, also to 100% for different technologies as well. Now is that I would like to give some brief intro as well, in of course to have a look at different electrochemical battery storage technologies. As I mentioned, that this is predominant in the Sub-Saharan Africa region. And one thing that's good to note is that the different cell and also battery chemistries for the electrochemical. And I would say I would like to, of course, start with lead acid, in that it's been, as I said, it's being predominant in the market, and it has its own set of advantages and disadvantages, like mentioned on the previous slide. That yes, it's of low cost, but looking into in terms of the cycle life, it's quite less, and also looking into the energy density, and also the disposal aspect. It's that is the key disadvantage for that. If you look into lithium-ion, for lithium-ion is that we have different technologies, or rather different cell chemistries, ranging from lithium-ion phosphate, lithium cobalt oxide, nickel cobalt manganese as well, and it has different application scenarios. So that is the advantages of now for the lithium-ion, is that you can have the batteries, but for different applications, depending on the cell chemistry. And the main consideration for lithium-ion, which lithium-ion technology to use, you look into different aspects, which includes the energy density. You also look at the cost as well, because they will all have different costs. And we will also look into the power density as well, and also the cycle life as well. So it all matters and it's all different. So like now, we can have applications from electric vehicles. We can also have applications in cell phones, in power drills, and also for energy storage solutions for the case of solar PV and other applications as well. Yeah, so just to give some basic concepts when it gets to electrochemical energy storage, we can look into the first aspect, that is the capacity. And I know this is quite simple, but it's also good to note that the capacity of the battery is good to very true about this, that the capacity of the battery is more of what is the amount of energy that can be stored in the battery, and the rating is usually either in ampere hours or kilowatt hours. So this is something to really note, because in some of the instances you find that of course you don't have understanding on where are you supposed to say the rate the battery in terms of watts or how are you supposed to rate the battery. So battery is usually rated in either ampere hours or the kilowatt hours. And also the other thing is the cycle. What is, of course, we've had so many discussions about what is a cycle. But maybe for lithium-ion, as mentioning that we can have up to 6,000 cycles. For lead acid, up to 2,000 cycles. But what do you mean by about the cycle? So the cycle, it's more of the time each and every time the battery is charged and also discharged. That is a charge cycle and also a discharge cycle. So charging the battery and discharging, that means one cycle. So the number of cycles that the batteries can be charged and discharged is more of the number of the cycle life that we're going to look into in the next slide. Then, the reason why we're discussing about this basic concept, because these concepts are actually very important, because it determines on which battery storage technology you are going to choose, and it also forms a basis when you're doing comparison of different energy storage technologies. So there's also the depth of discharge, in that it's what percentage, up to what percentage can you discharge the battery during operation. You can see that, as mentioned, you were very keen in the previous slide. You mentioned that for lead acid, the maximum days of discharge is 50%. For lithium-ion, let's say 90%. Maybe spark capacitors up to 100%. So it's how much energy you can actually discharge from the batteries. Let's say, I'll give an example. Let's say for a lead acid battery of let's say 200 ampere hours. So that battery can only discharge to a maximum of 50%. So that is the maximum capacity you can actually get from that battery, because that factor is very important, because you also need to factor that in your design as well. For lithium-ion, of course, we can go up to 90%, 95%, but there's always recommended to be able to achieve a certain number of cycles. And also to improve the lifetime of the batteries as well. So it's also good to check about this, that is in the specifications yet from any of the battery storage technologies that you're considering. So the state of charge is ideally on we can say the remaining capacity. So when the battery is fully charged, like to 100%, that means the state of charge is 100%. When you discharge, maybe 30%. So the state of charge is 70%. So it's more of 1 minus the DOT. Then the cycle life. I think I also mentioned in the previous slide in that different batteries have different cycle life, in that the number of cycles, the number of charge and discharge cycles. And it's also very important if you're comparing, that is apples to apples, you want to compare the battery technologies, you also need to know about the cycle life. Like for the case of lead acid, you can do, let's say, around 1,800 cycles, a maximum of 1,800 cycles. And also for lithium-ion, that is more than 6,000 cycles. For spark capacitors, let's say more than 20,000 cycles, etc. So with this now, you can easily determine on what is the lifetime of the batteries. I will use a case. I will use a case like with 6,000 cycles. Of course, I will leave it to you to do the calculations. Let's say your battery storage technology, like for the case of lithium-ion, where we are saying we have 6,000 cycles, and we assume that we are having one charge and discharge cycle per day. That is one cycle per day. That is, we are charging and discharging the batteries. That is one time in a day. So that means that in a year, having 365 cycles. So with now 6,000 cycles, so 6,000 divided by 365, so that comes to around 15 years. That is now the cycle life, or rather the shell life. So these are different because you can also use this to compare the different technologies. And the other thing is also the charge and the discharge rate of different batteries. So this is very important to understand, in that how fast or rather how slow can you charge the batteries, because they have different C rates. I'll give different scenarios and different examples. Like we have 0.5C, we have 1C, we have 2C. I know these are factors. If you've been working with batteries, you've heard about them, or you already know about that. And it's good to know because, as I said, it's how fast you can charge a battery. Like I'll give them a case for 0.5C. That means that the battery needs to charge the fastest you can charge the battery is in 2 hours. For 1C, that is for 1 hour. For 2C, that is ideally less than 1 hour, or rather in this case, let's say for 2C, this is more of 0.5 hours, that is 30 minutes. And the different batteries, different charge rates are for different applications. Like mostly for 0.5C, we are looking at applications for either microgrids and also C&I segment, backup storage, etc. For 1C, that is charging a battery in 1 hour. Of course, this is mostly for telecom stations, and also when it comes to C&I and also utility applications for frequency regulations and also demand response as well. So for fast charging batteries, that is 2C plus, 2C, 3C, 4C, 5C. So that means for special applications, like for the case of EVs, electric vehicles or other electric bikes, where you need to charge the batteries very fast. So it's this is a very important thing to also keep note, because ideally it also determines on the charging power, because there's certain rates that you cannot really exceed. So of course, when it comes to the energy density, that is more of volumetric. That is what is the total energy per kg or rather per liter. Also power density, that is the total power you can get from the battery, that is per liter and also per kg. Yeah, then now to, of course, for energy storage, is that I'll treat as a solution. And of course, the form that we are storing energy, we also need to do conversion. And I'll take a case for lithium, in that for you to convert the energy stored in batteries to a usable use. Let's say the batteries usually store energy in DC form, and you need to do for your loads, or rather for the application, you need to get AC power. So ideally is that you need to convert that power from its initial form, that is in DC to AC, and we use that to we use a power conversion system. And so what is a power conversion system? And as the name says, is that it's a system that is actually used to convert power. And they're different, because a power conversion system is not necessarily an inverter. And an inverter can be a power conversion system, but a power conversion system is not an inverter, because there are two reasons. And you can see ideally from my diagram, from this diagram, is that we have the battery system, and we have the power conversion system, or rather the PCS. And of course, these can be the grid or the loads, or that I can even have on with DSS as well. So the power conversion system is bidirectional, in that you can do conversion from AC, right, from DC power from the batteries to AC, that is usable for your loads, or rather the grid. And also you can use it to convert power from DC, also AC to DC, to be able to charge the batteries. In comparison to PV inverters in this case, is that of course we have the PV array in DC form, and from the PV inverter, and we get the conversion from DC to AC. So you can see it's necessarily unidirectional. So this is the main difference, that this is bidirectional and this is unidirectional. This is very important to note about that, because it's also very important for our next slide. We are going to discuss about AC coupling and also DC coupling as well. Yeah, so for DC coupling is that when we talk about DC and AC coupling is ideally we want to know is that are we coupling, or rather are we linking, or rather integrating the PV, the solar PV into the energy storage system. So there are two scenarios in that, or rather two topologies. You can couple or rather link from the AC side, or rather you can also couple from the DC side. Like for this case is that, of course, with the AC coupling, of course, that means that we are coupling from the AC side, where we require from power from the PV modules. Of course, we have the PV inverters doing the DC to AC conversion. Then we couple from the AC side. Then it does the conversion from the PCS does the conversion from DC, that is from AC to DC to charge the batteries, with the AC coupling systems. And AC coupling systems, of course, we have different scenarios. In our recommendation, we recommend that, of course, we use it for very large scale scenarios. That is ideally more than 2 megawatts for C&I and also and also looking into utility scale applications. For DC coupled solutions, this ideally for small systems, rather mini grid projects, C&I projects, residential, that is less than 500 kilowatt. And the other side, we are coupling the PV, or rather solar PV, from the DC side, where we have the PV modules through a DC-DC converter to the PCS on the DC side. Then it does the conversion from DC to AC. To now supply the loads. That is the usable form, that is the AC. So it's good to understand the different scenarios. And again is that
Titus, just a second, please. We have like 13 minutes left, so maybe if we can wrap up soon in the coming 2-3 minutes, so we can have some time for Q&A, please.
Okay, we are actually almost done. So
yeah, thank you.
Yeah, so thank you, Monif. And if you look into the C&I storage that, of course, available with different technologies, that we also require the energy management system. The energy management system, of course, to perform different functions from data logging, to be able to get data from either the batteries or from the loads, or rather from also PV in terms of the generation. We also need to control other factors as well. There is the thermal management system and also the fire suppression system for safety purposes. And also to control the charging and the discharging of the batteries, to be sure that you can be able to maintain the charge and also the discharge rate as well. So that's basically a brief introduction. So before moving to just show you some brief of what solutions we are providing to the market, that is to give for the different solutions that are residential and also commercial industrial. I would like Monif to just run a short poll question, just to get your feedback. So Monif, kindly just run the poll question.
Yes, I have it up now. If you please notice your screens and answer this question, we'd like to see what is your opinion or what is your expectation. What would be the best application for energy storage in Africa? For sure, all applications are valid, but which ones you think will take the most market share in the African region? So far, we see answers for all of the options that we have. The options that we have are like to use energy storage to support the off-grid applications. The second one is to provide grid services. Third one is to provide backup power. And the fourth is to reduce fuel consumption in combination with fuel generators. Maybe the question is incomplete on the screen, but what we mean there is to reduce fuel when we do hybrid solutions between energy storage and fuel engine generators. Most of the votes, like around 64%, say that it is to support the off-grid application. So the biggest expectation, by far more than the next one, is to support off-grid applications, and I think that's a clear answer from our audience. So what do you think, Titus?
I think actually it's what is expected, because if you remember the start in terms of the market drivers for energy storage, I mentioned that of course we have low electricity access and also poor grids in the region. So ideally we need to support that off-grid applications because of the low electrification rates. So thank you so much, Monif, and also thank you to everyone for participating in that poll question. So I would like now to just take some few minutes to show you on, of course, different solutions that we are bringing in, of course, if it's to support the off-grid applications and be able to understand different solutions. So we have different solutions that we, of course, bring in the market, and we've classified into three main categories. That is for the residential, as mentioned, commercial, industrial, and also utility scale. So for the residential solutions, these are the solutions that we are offering. You can always get specification sheets from us. You can see we having the batteries in battery cabinets, and also we have the hybrid inverters. So that means that the systems that we offer can either work in the off-grid and also on-grid applications. And for residential energy storage, we have single-phase and also three-phase solutions, depending on the requirements. And you can see we have different hybrid inverters, that is 3.6, 5, and 8 kilowatts. And also the energy storage, the corresponding energy storage solution, battery storage, that is 7.2, 9.6, and 19.2 kilowatt hours. For three-phase as well, it's the same case, that is 10 kilowatt and 12.5 kilowatt hour, or also 25 kilowatt hours. So that is for the residential segment. For the C&I segment, of course, as well, we having these solutions in either battery cabinets or containers that I'm going to show you. And remember, as I said, these are solutions. These are not batteries, these are solutions. That means that for the solutions, we have the PCS, we have the high voltage fuses, we also have the batteries in battery racks, and also the thermal management systems. So this is part of the solutions that we are offering. And yeah, these are snip view that is from a 10-foot container that is containing different components, in that it comes with the solution that is from the power conversion system, the batteries, the air conditioner, also the fire suppression system, and also the controller, which now houses the energy management system. So it's more of plug and play systems. You can see different scenarios, that is from 30 kilowatt to 64 kilowatt hours, all the way to 100 kilowatt and 384 kilowatt hours. And how we made the solutions, you can see how we made the solutions, that we made them that it can easily fit into a 20-foot container. We can have several units for these small solutions, that is for the 30 and 50 kilowatts, to fit into 20 and also 40-foot containers. For the solution actually more than 100 kilowatts, we have them that is built in 10-foot containers. And for the 10-foot containers, these are interlocking containers. You can interlock two containers to make it 20-foot containers for ease of shipping with all the components in place. And what remains on site for you as an installer, is an EPC or the client, is just to do some, of course, cable termination on site, and also some bit of civil works. So it lessens your installation time, and also the O&M as well. So, and also these are for the bigger solutions. There is from 250 kilowatt for the PCS and 276 kilowatt hour for the batteries, to all the way to 500 kilowatt for the PCS to 1108 kilowatt hours. And one thing about also all these solutions that we also offering is that you can easily have the units in parallel. Like now for these particular units, you can have up to 3 units connected in parallel, to be able to expand your solution. So that's briefly about my introduction and also the content. If you do have any questions, we are going to get into the Q&A section. And also, before we get to the Q&A, you can always contact, of course, can contact me. This is my email address. And you can know, as Monif said, you can also check on information that is educational content that we do post on our Facebook page that we recently launched, that is Jinko Solar Sub-Saharan Africa. Back to you, Monif.
Thank you so much for this informative session, Titus. So it's like a crash course for energy storage. For those who have a little bit experience in that before, or have no experience, or even work with storage, I think the content that you delivered today is very helpful, and that's why we got plenty of questions here in the Q&A section, in social media, and by email even we get a few questions. So we have 5 minutes left in the session. If you don't mind, we will extend for 10 more minutes. So we have total 15 minutes of Q&A, just because we've got quite a few questions to answer. And I hope that all of you on the call to bear with us in these extra 10 minutes. I think it's very important that we get into the discussion part. So the first question, I have it from Kadri Dalo Kadri from Ghana, and he says, okay, how would energy storage contribute to increasing the energy or to reduce expenses in a power plant in general, like PV plus storage, especially that you say in your presentation that storage will help to reduce LCOE, but we know that lithium-ion batteries are expensive. So is this contradicting, or it still makes a lot of sense to use lithium-ion batteries for utility scale applications, especially?
Yeah, I will actually explain in this way, in that I will use a scenario, let's say the generation for your PV plant, let's say for a C&I application, let's say during midday when this irradiation is quite big, and also of course there's too much generation from the midday. But if you look into, let me assume that that is lunch hour period and there's no production ongoing in the factories, or rather the loads are quite low. So ideally that, yes, this huge production, but that is not being used by the loads. But now with the energy storage, like for the case of lithium ion, you'll be able to store the energy storage later use at periods now when you need the demand. And if you look at the costs, now looking into the cost of the energy storage that we are looking into, we are not focusing more into the absolute cost, that is the capital expenditure. We're looking into the levelized cost of storage. So because we are doing now the cost of storage, factoring also the capex and also the opex, that is for the lifetime of the solution, let's say 15 years. So the total cost, that is the average cost for the 15 years, would really make a lot of sense compared to getting this power from some of the grids when we have, of course, when the tariffs are quite high. So it will really make a lot of sense.
Mm-hmm. Perfect. Then maybe, thank you for the answer. Then I will just complement it from another question from Irahali Ben Said. I hope I'm reading the question, the names properly. Asking about, let's say, the common applications for storage in Africa and the references of Jinko Solar in this regard. Did you have projects in Africa with energy storage for Jinko Solar?
Yeah, as I said, these are storage solutions that we've been piloting for almost 3 years, and also we are partnering with some of the key OEMs in the sector. So the solutions that we have actually been installed in more than the last 10 years. But in terms of our solution is that we've been piloting in North America, also China, and in some part of Africa, and also Middle East for the last 3 years. That is from 2017 to 2018. So we have some solutions that have already been deployed in the region, and in the Sub-Saharan Africa region, and also other parts of the world. And also looking into the technology itself has also been deployed in the last more than 5 years as well. So we have some reference, and this can always be shared to anyone that is on request.
Perfect. Perfect. Okay. Thank you for the answer, Titus. Actually, we received, I think, more than 5 questions from Irahali. I hope that we will be able to go through them all today, but there's just a second one from him asking about a simulation tool for energy storage, like especially if you want to do an energy yield simulation from a PV plus energy storage system. He says that she says that the PV system is still using a simplified model for energy storage solutions. Do you recommend any other tools, or what do you use yourself for that?
Yeah, actually, for energy storage, it makes for, of course, when you talk about energy storage, you are talking about hybrid solutions. And talking from my own perspective and also from my own experience, is that I've been using OMA Pro for the longest time, and it's really serving me well in terms of simulations, because I can also do a financial modeling as well to be able to see on which technology is ideally competitive. Well, especially when working with, let's say, solar PV, you're also working with wind, you're also working with, let's say, hydrogen, you're working with lithium ion. So OMA Pro, to me, it's really been very helpful. So that is from my experience. So I would recommend that you can use OMA Pro, that is to do your modeling.
Mm-hmm. Perfect. Thank you, Titus, for this recommendation. I hope it will be useful for Rahali. And I'll move next for a question from Southern Africa, from Nonkululiko Madondo. I hope I pronounce your name properly. And he's from BBCBE Youth, and asking about the role of youth in the renewable energy storage market in Africa, which I think partly, I think we can maybe, I don't know if you agree with me, Titus, like the energy storage solutions are new in nature. Yeah, even if you have 10 years or 20, 30 years of experience in energy sector, it doesn't mean that you are a master in energy storage. It's a new field, new technology. Every day there's something new. And I think it puts people with 1 year of experience and almost in level with people with 10, 20 years of experience when it comes to new technology to be used for storage. So I think it's maybe a great opportunity to integrate youth into this segment. I don't know if you share the same opinion with me, Titus.
Yeah, I would, of course, give a real life scenario.
Titus, I'm not sure if you can hear me.
Yes, I can hear you. Can you hear me?
Yes, I can hear you. We just got interrupted for like, didn't hear the answer. If you just start saying it again, please.
It's okay. So I was just saying that if you look into generally most of the owners of most of these renewable energy companies, or rather solar PV companies, not only in Africa, you can also do your own assessment. You can see that most of the shareholders are actually young people. That is, I would say young in sense of under 40. And most of also the players in the industry are also quite young. The reason being because of the rapid developments. If you see, like now, the developments in energy storage, there are new developments each and every day in terms of technology, and even the existing technologies keep improving as well. And it requires, of course, some very energetic persons, so really in this case, the youth, to be able to advance these developments and also, and of course, adapt to the new developments as well. So it's the reason is because of the rapid developments in the sector. Mm-hmm. Not only battery storage, but generally renewable energy.
Thank you. Perfect. Perfect. I'll move then next to the question from Joseph Kimani, who sent multiple questions. I'll be reading one of them, who's asking about the warranty for energy storage solutions. What is the warranty for such systems typically, and what do you offer as Jinko Solar, especially when we come to maximum cycles for lithium-ion batteries?
Yeah, so the warranty will vary because of depending on the technologies and also the cycle life. Like I will give a case, like most of lead acid and lead carbon usually do between 2 to 5 years. And if you look at lithium ion, mostly between 5 to 10 years product warranties. So as Jinko Solar, because that is where we fall in, we usually do either 5 or 10 years warranty depending on the cost. because I would give a case because the reason why we give to either 5 or 10 years, because if you want to have 10 years warranty, there are some of the components that ideally need to be replaced, let's say after 8 years. So for the 10 years warranty, we need to factor in the cost of the replacement, and the cost of replacement is quite small. So the difference in the warranty for 5 years and 10 years is quite small. So we can do a maximum of up to 10 years.
Okay, perfect. I think this brings us to an important question that has repeated multiple times. Like, where do we buy Jinko Solar products? Panels or energy storage in Kenya, in Ghana, and I've seen it in a couple of other countries. So in general, in Sub-Saharan Africa, if people want to buy your products, where can they go, or who should they call?
Yeah, for our solutions is that what we've done, we've tried as a manufacturer. Yes, we have factories in China, and also in Malaysia, and also Vietnam, and also the US. But we try to localize and have the products readily available. And what we are doing is that we have distributors in almost key countries. Like now we have a distributor. We have 2 distributors in Kenya. That is Creative Innovations and Nabico. We also have distributors in Tanzania. That is Enson. We also have other distributors in Ghana as well, and also in Nigeria. So we've tried to have distributors in almost almost the key countries to serve certain regions. Also for South Africa and Zimbabwe and Zambia as well, we also have distributors in those regions as well to be able to service their clients. But if you're looking into the bigger solutions for the energy storage, like more than 50 kilowatt to 64 kilowatt hour to, let's say 1 megawatt hour, we prefer that you directly get it from China. Because of also the production time and also the customization based on the requirements. So yes, for the PV modules, it's quite easy because you can easily have them in the distributors. For the residential energy storage, you can get that directly from our distributors. But now for the C&I energy storage, it's preferably to get that directly from China.
Okay, perfect.
And also lastly, something about that is that we also have sales managers for all the 3 regions. That is East Africa, Southern Africa, and also West Africa.
Perfect. So if you send an email to Titus at the email that is on the screen now, he will definitely direct you to the right people to discuss. So please take note of the email while it is still on. I have a couple of questions then from our friends and big enthusiasts of renewable energy and energy storage, and some of the pioneers in Northern Africa and Middle East. I have one from Dr. Abdurrahman Boubraik, who's interested to know about the source of the study that you presented in the slide Technology Relevance 2016-2030, and based on what parameters were these expectations for the future storage technologies till 2030. So just as a source of the study, is it something like from Jinko Solar, or you used some external study for that?
Yeah, I think I've mentioned on my slide, I've actually mentioned the source. That is the US Trade Development Agency.
Okay, perfect. And it will be written on the slides that we will be sharing as well. And the second one from engineer Zuhair Hamid, who's asking about the cells of your batteries. Do you manufacture your own cells as Jinko Solar, or do you use cells from other vendors?
So currently, is that as I said, we are using lithium iron phosphate, and of course, lithium iron phosphate is not a new technology, so we are not really manufacturing it ourselves because we don't have any batteries. We don't have any many factories for manufacturing batteries. But what we are doing is that we are working with top battery manufacturers. If on request, you can request you want to exactly know which battery manufacturers we work with. I can always tell you on a personal level on which battery manufacturer we work with. But we are working with top tier 1 battery manufacturers for the battery cells.
Perfect, perfect. Thank you for this. Okay, there are still plenty of questions, but there are 2 people who didn't answer any of their questions yet, and we'll try to do it in the coming minutes. So Aaron Uba is asking, how do you determine the state of health of the battery using DOD with your BESS? So how do you determine the health of battery then, please?
So ideally, what we do is that with our solutions is that each and every battery, that is, of course, we have the battery cells. Then from a combination of a set of battery cells, we get to the battery pack, and a combination of battery packs we get to into the battery rack. So from the battery rack, from the battery pack is that we monitor up to the cell level. In that every battery pack will have a battery management system. So it will actually, the battery management system will now communicate to the battery cluster management system, cluster management system, of which we relay that information from the battery cluster management system to the EMS. So we are monitoring up to the cell level. We're using the EMS, which is attached. Yes.
Okay, perfect. Thank you very much, Titus. From there we have still 10 questions. We'll try to get to you probably by emails later for these questions, especially the ones that are like the question from Faris Aziz about the molten salt technology. It's a little bit, this session is too short to discuss all of the storage solutions. We focused on the battery energy storage in this session. I promise to send you by email some resources to read, and I hope we have sessions dedicated for molten salt as well in the future. So it's time to end this session. So first of all, I wish to thank you, Titus, for this very informative and useful educational session where you really helped us to demystify a lot of concerns about lithium-ion technology and how it is suitable for big-scale energy storage solutions in Africa. For the people that are watching us, please, if you found this content useful, please follow the Jinko Solar Sub-Saharan Africa page on Facebook. We'll be always posting useful and educational materials almost on daily basis, and you will have access to the recording of this webinar as well. I thank you very much for attending this session, for your questions, for your follow-up questions that we failed to answer due to the time constraint, but we're very happy to have you with us on the Zoom platform here and in social media. So I wish you all a sunny day. I wish you to stay healthy and safe until we meet next time in the coming episode of this educational series from Jinko Solar. Thank you very much and have a good day.
Thank you so much, Monif. Thank you, everyone.
Thank you, Titus.